Welcome to SPC Insights with Dr. Bill, simplifying SPC and statistical analysis. This video is going to take a look at variation in histograms, in particularly how you can use a confidence interval with a single histogram to find a range of potential out-of-spec product. This video, we're going to start with a histogram review, talk about our simulation data, talk about the impact of variation on histograms, particularly the out-of-spec, and then we'll finish with a summary. So let's start with the histogram review. Along the x-axis, the horizontal axis, that's the measurement. The frequencies along the y-axis, it's measuring how often a range of values occurred during our given time frame. Histogram tells you four things: the most common value, which is the high point, the amount of variation present, which is the spread of the histogram, the shape of the variation, is it bell-shaped or not, and then finally the relationship to specifications. Here our upper spec is 120, and we have a few points that looks like above the upper spec limit. So with our data, we simulated by generating 10,000 randomly generated points from a normal distribution with an average of 100 and standard deviation of 10, upper spec of 120. You can download the data and the simulation results from the link below. So there are some samples that are above the upper spec limit. 227 samples are out of spec. That's a value of 2.27%. That's the real value. So we're going to use these 10,000 points to see what variation does to histogram made from samples. So suppose we have data for a monthly report that includes a histogram with 100 data points. We go out and randomly select those 100 points from the population, and here's our histogram for that. You can see that there are 3 points above the out of specification. If it was 100% inspection, you'd be done then, but it's not. We are sampling the process. What's that mean to sample the population? Here's the histogram we got, but we're not measuring everything. We're just taking samples. What we hope is that these samples represent the materials not measured. In other words, this histogram is really similar to the population. We want to make conclusions about the material not measured based on the samples taken. And you can only do that if the process is in statistical control. But there's still limits there. The problem you have, here's our population again. This histogram has 3% out of specifications. So since your process is in control, can you expect to have 3% out next month? No, you got to remember variation. Even if the process is in control, the next month's histogram may or may not have 3% out of specifications. So let's take a look and see what really happened when we take our second months of data. So here's the first months of data that we had. We had 3 points above 120. Here's the second point that we have. Lo and behold, we don't have any that are out of spec in this case, and the shape's a little different, but that's all due to variation in our process. Histograms are going to give slightly different results. So what we did was generate 100 random histograms and determine the number of samples that are out of spec for each histogram. And here are the results. There were 0 out of spec 14 times out of those 100, 1 out of spec 18, 2 out of spec 36 times. That's the largest that we had. That's the mode of the histogram. Then we had 5, 6, and 7 out of specs. That happened 1 time each. So we went from 0 to 7 out of spec. Now, how can you estimate the percent out of spec from histograms? You can do that, but you have to use a technique that takes into account variation. And that technique is called the Agresti-Coull Interval estimation. It starts with a Wilson point estimate, which is the number of out-of-spec samples plus 2 divided by the total number of samples plus 4. And then we have an equation for 95% confidence limits. It's the point estimate plus or minus 1.96 times that square root term. So let's figure out how we do this. Go back to our first histogram that had 3 out of points. In this case, the Wilson point estimate is 4.81%. That's out of spec. And we can then use the 95% confidence intervals, and we get a range of 0.7% to 8.92%. A very big range of what could be out of spec from the histogram. Now here's the one that had 0 out of spec. In this case, the Wilson point estimate is 1.92%. And you can put in your confidence intervals, and it goes from 0 to 4.56%. So even if your histogram doesn't have any out of spec, it's possible that there's some there. And if you can do this for all 100 points, you can see our chart here where we have the lower, the Wilson point estimate, and the upper. There's a lot of variation in the results you can get from histograms. So, in summary, we have to realize the limitations a histogram has, even with a lot of data. A single histogram is not a good indicator of how much out-of-specification product you have. You have to account for variation. And the Agresti-Coull Interval does this. You do the Wilson point estimate, and then you can do the 95% confidence intervals to find the range of potential out-of-spec product with your histogram. So thank you all for watching our SPC Insights. Click on the YouTube button to subscribe. Please visit our SPC Knowledge Base or download our software to make your own control charts. Once again, thank you for watching the video.